I wanted to make a video sort of trying to consolidate some information that to do with pitch structure and the harmonic series and how pitch kind of arises in its natural form before we tend to organize it into this 12-tone system. The idea I was hoping to do was, because when I've been looking into it, I feel like I've been looking at quite a few different places and trying to piece it together, and it was a little bit confusing. Now I have a little bit of an idea. I wanted to try and put some of the knowledge in the same place and as simple as possible, just to save some time. If anyone's trying to look into it, the idea would be to save you some time, just to have this info in the same place. I'm not an expert on this. There's a few things I'll link in the description, the things that I found really useful. There's one chap, Brenan Silvius. His videos were really good. He's a singer and does it with the voice. It makes a lot more sense with the voice, to be honest. And also Jakob Pek, his videos are really good. So I'll put some links in the description to do with that. They probably know a lot more about it than me, but I'm trying to put it in a simple way. Just put some info in the same place, and try and get the info together in a way that's simple and in the same place. So what I played first there was I guess that you sometimes called the natural harmonics, or the overtone series or the harmonics series. And any stringed instrument, the guitar is quite a good example because the frets make a good visual reference for finding it. But essentially what you're doing is dividing the string up into different amounts equally. So when you play if you just play the 12th fret, what's really happening is the active length of the string, which is the nut to the bridge, the 12th fret is exactly halfway. So when you're doing this, you're halving the wavelength, thereby doubling the frequency, and that gives you the sound of one octave up. So you may know on the guitar, you can play a harmonic on the 12th fret by muting it, just slightly touching it, and then letting go, not fretting it all the way down, and then letting go. What's happening now is we've muted it here, so we have this kind of node here, and the string is wobbling on both sides. So we're getting the same pitch as if it's like this, one octave up from the original sound. They kind of have their own tone. They kind of ring in the same way as if, they kind of ring in the same way as if it's the full length of the string, because it still is in a sense, but it's just the pitch is that of this note. This is just, so this is essentially, you could describe this, because with half the length of the string, doubling the frequency, this is like a ratio of 2 to 1. And you might hear this terminology, the first partial. If someone says the first partial, then probably just mean this. And then the second partial is just this. So if we were to continue this principle on, we've split the length of the string into 2. So what if we wanted to split it into 3 equal parts? So we've got 2 equal parts here. What if we wanted to split it into 3 equal parts? So if you want to do that, the place where you mute the string 1/3 of the string length is roughly pretty much on the 7th fret. And what this gives you now is, so this first sound, you might recognize the pitch already, so this is our first partial. It sounds 1 octave up. Pitch-wise, we're perceiving this as being a 5th up from this. If you listen to the sound, it's a very familiar sound in music. Hopefully it's familiar sounding to you. It's the sound like. So it's a 5th up from the pitch you get with the second partial, and therefore is an octave and a 5th up from our original note, the first partial. And this is a ratio of 3 to 1. So we split the string in 3, you get an octave and a 5th up, or that's how we're perceiving it. It's important to draw this distinction between, sometimes when we're using these terms like a 5th, it doesn't translate that well into this way of thinking, because that's terminology is usually assuming that you're using what we call equal temperament, which is where essentially it's a system of dividing the pitch up, which is not in tune according to the natural harmonic series, but it's done so that you're able to play multiple different keys. If you tune this way according to the natural harmonic series, everything will be relative to the note you began with, so you'll be limited to playing in that key. But if you ever hear this term just intonation, this is like, this pitch is a just intonated 5th above this pitch. It's a true natural 5th. Like I said, these terms don't really translate well, so if you're learning this kind of thing, you're probably best off just letting go of any preconceptions as far as, in thinking of like intervals, like, 3rd, 5th or whatever, and just going with a blank mind, kind of, and hear the sound. So this is what we have so far, and this is why the 5th, keep using this term, but the 5th is so fundamental in our music, it's all over the place. It's probably the most, one of the most fundamental sounds, this, to us. So if we continue further, this is 3rd partial, 3 to 1, 3 to 1, 3 to 2. So okay, what would be next then? If we split the string into 4 equal parts. Now the point here is, your rough point of reference if you're using a guitar for this is going to be pretty much on the 5th fret. And now we have another E note, 2 octaves up from our original first partial. Sometimes called also the fundamental. I think the thing on certain instruments, certain tones, it happens with distortion, you can hear these sounds within this. When we're hearing this, we're also hearing these extra tones within it, very subtly. Depending on the instrument, you will hear them more or less, but they're kind of there, you're perceiving them probably subconsciously. This here, 2 octaves above our original, 1 octave above this. So total 2 octaves now. This is the 4th partial. We'll talk more about this in a minute, but you'll see how any number that's basically a square number is just going to keep giving you an octave. If you just keep multiplying by 2, you've got this original. Okay, then we multiply by 2, multiply by 2 to 1. Now we've got 4 to 1. That's an octave from there. If you did 8 to 1, that would be another octave up. Because if you have a frequency, 1 octave above that is by doubling. 4th. It's not right on there. You can still get it if you go right on there. I find it's clear as like just before. And what this gives you now is a major third, or it's not really a major third, it's a just intonated major third if you want to call it that. That's a quick aside that's definitely worth doing to feel tuning and things. If you have the amp loud enough, well, as it is at the minute, and the sound is quite full in the room, it will be going into your body. If you try and hum along, with your mouth shut, you can really feel when your humming is in tune with the note and when it's slightly out, because you can physically feel the vibrations and the beat cancelling. I'd recommend trying that. It's very much like if you have a camera with a lens that you can go like this on. When your humming is like slightly above or below, it's a bit blurry. So you turn the lens and it comes into focus, and this cancelling, this wobbling sound, the beat cancelling, it becomes more still, it becomes more focused. So this is the 5th partial now, as it's called, because we've got 1, 2, 3, 4, 5. Helps to have it on the bridge pickup and the volume nice and loud. Pick a little close to the bridge quite hard. You can get it nice and clear. And you can get it nice and clear like that. So this is the next most natural interval for most of us to hear, is this major third. Now we've kind of got the ingredients, what we would need for a major triad. So a good way to, you can carry this on further, which I'll show you the sound of. That's pretty much just after the 3rd fret. And it gives you a B note that's kind of like a 5th again. That's a flat 7, or it's a just intonated flat 7. It's really, try not to, naturally we will always try and, if you come from a background thinking of in the 12-tone system, you'll probably end up comparing it to that. But if you just at start try and just listen, with a blank mind, it's like a flat 7. And now this is the 8th partial, and that's why we've come back to E. I think of those as roughly either side of this dot here. I don't know if you can see that on the 3rd fret. I think of them. They live kind of roughly either side of the dot. So the easiest way to remember this is very straightforward. The notes this basically forms is this. E bar chord. You can probably hear the tuning if we do a quick test. You can hear that's not quite in tune because I tuned the guitar not using this as a reference. So if you were to get this chord really in tune, you can hear now that's gone more still. So if I play this chord again, it's kind of ringing a bit different. It feels a bit more focused. The trouble is, as we were saying earlier, if you tune this way, relative, using this just intonation, you're limited in a sense. Like if I play a different kind of E chord now, it'll probably sound out of tune. That not good. So this is why we tune a little bit differently generally. to make things a bit more even across the board and allow you to play in different keys. But this is, if you want, this essentially forms the harmonic series, this chord shape. It's just like going. So, just to summarize what we've looked at there, as far as the ratios of the overtone series, the natural harmonic series, I've just drawn it here as a quick reference. You can pause this and make your own copy or something. There's information all over the place, but this is what it looks like. There's this section here. You've got essentially, as we said, first partial, second partial sol, and the equivalent, if you want to think of it this way, sometimes it doesn't make a lot of sense to think of it that way, but just to give you a point of reference, I've circled the prime numbers because those are the ones, anything that's not a prime number can essentially be constructed using products of these primes because it's multiplicative. So we're going to use that to think about how you could, I'd like to show a couple of examples, but you can essentially use that to build a just intonated version of the chromatic scale. And I'll show you the ratios first and then show you how they're derived. This info is all over the place if you Google it, but you will probably look at it. The thing I was having, I was looking at it and just didn't understand why, like why is so-and-so 3 to 2, like what even is that, why is it that? It's not that complicated. What you can prove why it's that, and hopefully we'll do that in a minute. So I'll show you something else now, and this is if you look in the top left here, this is very much like a chromatic scale, except it's just intonated. So what we have very often when people are talking about tuning systems, if they're talking about just intonation, they use these terms, which is kind of like do, re, mi, etc., but it comes from like Indian classical music, and the reason they do that is to draw a distinction between equal temperament terminology and just intonated terminology. So you've basically got, if I just say the words, so you will probably hear these if you're looking into this topic, researching it: sa, re, ga, ma, pa, da, ni, and then back to sa. And that sound is kind of like a major scale. You have these prefixes before them, komal and tivra, and this pretty much in basic refers to sharp or flat. So if komal is like flat, so komal re is basically a minor second. Komal ga is basically a minor third. Tivra basically means sharp, so tivra ma is like a just intonated sharp 4. So this is the chromatic scale. If you just look at the ones without the prefixes, that's the major scale, but just intonated. So what I'd like to show how to do is, with just a couple of examples, how they arrive at those ratios, using this as a reference, the natural harmonic series. So you could do this in a number of ways, like very, I guess in ancient times almost, or I'm not really an expert. If someone knows more about it, do comment and let us know. But in ancient times and maybe medieval times, they found pitches essentially by stacking fifths. Well, stacking fifths is probably not quite right to say, but by stacking this, because as you know, if you're familiar with the traditional cycle of fifths, whatever you want to call it, if you keep doing fifths, you will encounter every note in the 12-tone system. However, if you keep applying a just intonated, we'll call it the third partial rather than a fifth, just to draw a distinction between equal temperament and just intonation. If you keep applying that, if you keep multiplying by 3, if you like, the thirds that you get are quite out of tune. So that's why I think, ancient music, medieval music maybe, you hear a lot of like, just with drone fifths and things like that, not too many thirds, because they would have sounded out of tune. So I think that's why. If you use not only the 3-to-1 ratio, but you start to think about the 5-to-1 ratio as well when you're constructing your system of pitch, you can obviously get an in tune major third, because that's what that is basically. So it's going to open up a few more things. Theoretically, you can, so just to clarify here, if you hear the term 5-limit tuning, that means you're using the prime numbers up to and including number 5 to construct your pitch system. There is such a thing as 7-limit, septimal tuning. I don't know anything about it, so I'm not really going to comment on that. But obviously 7 being another prime number, so you could use that in your construction of the pitches. But we'll focus on 5-limit because that's quite practical. You can think about it that way. So if we think about an example, how could you find an interval? Essentially by using only prime numbers up to and including 5. So that gives you 2, which is going to let you go up or down an octave, because you can basically divide as well as multiply. You can use 3, which is going to make you, if you multiply by 3, you're going to go up an octave and a fifth, or if you divide by 3, you're going to go down an octave and a fifth. Or you can use 5, which if you do that, if you multiply by 5, your pitch is basically going to go up 2 octaves and a third, down 2 octaves and a third if you divide. Just to reiterate, I'm using these sort of intervallic terms. This is, when we're using ratios, it's just intonated version. I'm just very used to these terms. So how could we do that? If we keep thinking in the key of E then, or E is our home, just, you might have a guitar watching this video, so if you think of a note, we'll play this E. Let's say you want to find, say, a major 7 interval using the fifth, your tools are basically an octave, a fifth, and a third. They're your tools. So what you could do is, we know, or you may know, if the major 7 interval, you will reach it if you jump a fifth, and then you jump a major third from that. So that's what we're trying to reach, and you can do this if you imagine, okay, we're going to try and get to this note. Well, what's going to happen there is, if you use your third partial, you'll end up over here, because you'll have gone an octave and a fifth, because that's what this is. From this note, if we're saying that, that's our fundamental. And then you can divide by 2 to go down an octave, and you end up here. Okay, so now that's why a fifth, rather than an octave and a fifth, is 3 to 2 rather than 3 to 1. 3 to 1 would give you an octave and a fifth. So you have to, put the 2 on that side to bring that up an octave. So the gap is this rather than this. So this is the principle we're going to be using by essentially applying these. So you can work stuff out, if you work it out on paper, it can be a bit tedious, but you can prove things this way. I'd like to show a diagram that people often use to explain things. It's called a lattice, and it's just a way of organizing the notes. This is a 5-limit lattice. We'll use this to derive these ratios, and it's this big picture, the sideways one here. So you can see what you've got there. You can see what you've got there is the 12 tones basically. And the way it's structured, let me get my glasses. The way it's structured is that basically if you go from here to here, that's going up a fifth. And if you go from here to here, that's going down a fifth. If you go from here to here, that's going up a third. And if you go from here to here, that's going down a third. And it's the same like if you're here and you go there, it's gone up a fifth, down a fifth, down a third, so on. So what I've done is, this makes it easier to think about, I've found. I'll put a key on the left here, so pay attention to that if you can. And what I've done, these are just octave adjusted versions of the natural partials basically. So instead of this being an octave and a fifth, we can treat this like this with the dividing by 2, that is timesing by 2 to the -1 to balance it out. So it's now no longer going an octave and a fifth, it's just going a fifth. So what we can do is we'll use this to derive an example in a moment. Just a quick reference. You know, if you times by 2, you go up an octave, and if you divide by 2, you go down an octave. So what you can do is, let's say if we take an example then, if we can try that that major 7 example just to see what happens. And I've gone through and tested this, and it does work for all the intervals. So let's say, okay, we're starting on E. So it's important, if you're looking at this lattice, you need to really start on this location, because let's say if you made your home this here, we can see we could get a major 6th F to D by going this way, but that way the ratio you'll end up getting if you go da 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 da, it's a different ratio than, you know, if you went a major 6th like E to C sharp. It's a different ratio what you'll end up getting if you follow that through. This would be like if you're using just the fifths, sorry, I should say just the third partial for your pitch structure system. That's also known as the Pythagorean system. That's what they used in ancient times and, you know, medieval times and stuff. It will be kind of different sounding. It'll be slightly different ratio. It'll still be perceived as a D, I think. You know, it'll still be close enough, but it will feel a bit different. It'll be a bit sharper or a bit flatter. So you want to start on this location. And the way you would do it, so let's say if we want to find, you know, the interval, sorry, the ratio for a major 7th, what you might want to do is just look at this lattice, look at this graph, and you can just follow visually what might happen. So if we say we're going to go up a 5th, and then we're going to go up a major 3rd, we know this is a target. If you just say to yourself, what's a major 7th above E or D sharp? Okay, how do I get there? I can go this route. And sometimes you may have to octave adjust it. You don't in this case, because if you go up a 5th and up a 3rd, that is the actual major 7. That's normal. But if you wanted to say go, you know, E to C sharp or something, then you probably have, this would be going up a 3rd and then down a 5th. You'd have to octave adjust this, make it go up an octave, otherwise you've gone to the major 6 below, if that's what you're trying to study. So we'll just do a quick example here then. Let's just show this, how this major 7 one works. So if we're going to go across here, we're going to add this to our formula, and then we're going to go, which is up a 5th, and we're going to add this to our formula, which is up a major 3rd. And hopefully we'll end up with this ratio, Ni, which is 15 to 8. So the way that would work, if you were to just write it out on pen and paper, hopefully this is not too not too high school Mathieu, but hopefully it's okay. So if you're going up a fifth, you're basically going to be thinking you need to times 3 to the 1, and then, which we'll just copy from the key here. And then if we want to go up a third as well, we're going to have to introduce this, which is going to basically be 5 to 1 and 2 to the negative 2. And we don't have to octave adjust this. If we wanted to octave adjust this, we'd just add we'd multiply by 2 to the 1 or 2 to the negative 1 if you wanted to go up an octave or down an octave, but we don't want to do that here. So we'll just see what happens. So when we get this, we're going to end up with basically 5 to 1, 3 to the 1, and 2 to the negative 3. And really what this is that. Really what you've got is this to the 1. So if we want this more readable, if we want to simplify it, we'll end up with something like this. We're just going to multiply both sides by 2 to the 3 to cancel this out. So 1 times by 2 to the 3 is 2 to the 3. 2 to the 3 is 8. 5 times 3 is 15. You end up with 15 to the 8. 15 to 8, sorry, which is the same as our knee, which is major 7. So that's how this is derived. I'd like to show one more, which uses octave adjustment, just so you know what that looks like. But if you wanted to go away and do this just to help you understand it, that would be a good exercise, even though it's very tedious. But we can do another one that's not too complicated, and that would be finding, let's say, a major second, which would be a major second above E is F sharp. So we can see the path we want to take would be going up a fifth and then going up a fifth again. Now you see, if you've gone up 2 fifths, you've not really gone up a major second, you've gone up a ninth, which is a major second and an octave. So to find the major second, you need to octave adjust it down 1 octave, which is just adding, multiplying by 2 to the minus 1, i.e. dividing by 2. So we'll just do that now, just to see what that looks like. So what we're going to do is take this formula from going up a fifth. So we're going to have, that's the first step of a fifth. And then we're just going to do the same thing again, because we're going to go up a fifth again. Now we're going to octave adjust, which means we want to go down 1 octave. So that's what we're doing. We're just multiplied by 2 to the negative 1 just to go down an octave. Now, so we've gone up a fifth, and down an octave. So what you would end up here then is 3 to the 2 multiplied by 2 to the negative 3 to 1. So how would we, make this look a bit nicer? Same kind of principle. So you'd have 3 to the 2 to 2 to the 3, which if we, all we've done is times this out, and then you end up with 3 times 3 is 9, 2 cubed is 8, you end up with 9 to 8, and that matches our Ray step, which is the just intonated version of a major second. So if you wanted to go and explore these, you can do this. I've tested these, and as long as you start here, it works. As long as you, and remember to octave adjust. You can find every just intonated version of everything in the 12-tone system that way. And that is, just to reiterate, that is using a 5-limit system, because we're using the primes up to and including 5. We're not using 7 and so on. So that's kind of an overview, and I guess that's a lot to take in, but I wanted to try and put together something which which encompass a bit of info from these different places and tied it together in a way that's hopefully not too confusing and rambly. But like I say, do check out the videos. I'll link in the description because they'll probably do a better explanation than me. But it's in different places. The info comes from different places. If you do have any questions, do comment. I'm not an expert on this, but yeah, thanks for watching.